Computational Sustainability by Mariah Scott. Why is this topic important in 2025? Climate change and environmental degradation remain pressing global challenges. In response, technology has emerged as a crucial tool for developing scalable, data-driven solutions to manage Earth's limited resources more effectively. As of 2025, there is a growing international emphasis on advancing sustainable development through innovations in AI, the Internet of Things, and big data analytics. With many nations committed to achieving the United Nations Sustainable Development Goals, the role of computational sustainability has become increasingly vital in driving environmental progress and fostering long-term ecological balance. Explain your topic in relation to technological advancements. Computational sustainability is an emerging area that blends computer science and real-world environmental challenges. It focuses on using technologies like algorithms, AI, and data models to create smarter ways to manage resources, protect ecosystems, and design sustainable systems. This includes things like improving how we use renewable energy, tracking endangered species, or planning eco-friendly cities. Recent advances in technology have made this work more powerful and practical. AI helps predict things like energy needs or climate changes. Machine learning can track animals or predict crop growth. Tools like AIoT collect real-time environmental data from sensors placed in cities, forests, and oceans. Cloud computing lets researchers process huge amounts of information quickly. These tech developments are helping us create real-time solutions for some of the biggest environmental problems today. As we move forward, computational sustainability will play a bigger role in making sure we use technology to build a more sustainable future. So the first article is AI for Earth, Leveraging AI to Fight Climate Change by John Smith. In this article, AI for Earth, Leveraging AI to Tackle Environmental Challenges, Mary Smith and John Smith explore how AI is being used to address some of today's most urgent environmental issues. They explain that AI can help in areas such as biodiversity, conservation, water resource management, and climate change. For instance, AI is used to monitor wildlife, predict environmental threats, and manage natural resources more efficiently. Summary of Article Part 2. The authors also discuss how AI can improve climate models and help optimize renewable energy use. Overall, the article shows that AI has great potential to support sustainable development, but it also points out the importance of using these technologies responsibly and working across different fields to make sure they have a positive impact. Relation of article to topic. The article directly relates to the topic of computational sustainability by demonstrating how AI can be practically applied to solve real-world environmental challenges. It supports the central idea that advanced technology, especially AI, plays a critical role in developing sustainable solutions to global issues such as climate change, biodiversity loss, and resource management. By highlighting the use of AI in monitoring ecosystem, optimizing renewable energy, and improving climate change predictions, the article reinforces how computational tools can drive meaningful progress in creating a more sustainable future. This connection emphasizes the importance of integrating computer science with environmental efforts, which is at the core of computational sustainability. Article 2, Smart Grids and AI Optimizing Renewable Energy Systems by Dr. Emily Zhao. Summary of article. In the article, Optimizing Renewable Energy Systems Through AI, a review future prospects. Explore how AI can enhance the efficiency and reliability of renewable energy systems. The authors review AI techniques like machine learning, neural networks, and fuzzy logic, focusing on how these tools can help optimize energy forecasting, system monitoring, and smart grid management. They highlight that AI can improve resource assessment by accurately predicting solar and wind availability, help detect and correct system inefficiencies in real time, and balance energy supply and demand through smart grid technologies. The article emphasizes that AI not only reduces operational costs, but also supports the broader adoption of renewable energy by making it more stable and competitive. The authors conclude that AI is essential for advancing renewable energy goals and call for continued research and development in this area. Relation of article to topic. This article directly supports the topic of computational sustainability by showing how AI can optimize renewable energy systems, which is a key aspect of managing resources in a sustainable way. It highlights how AI makes clean energy more efficient, reliable, and accessible, which aligns with the overall goal of using technology to solve environmental challenges. By improving how we predict energy production and manage smart grids, AI helps reduce reliance on fossil fuels and promotes the use of renewable sources. This reflects the core idea of computational sustainability, applying advanced computational tools to support long-term ecological and energy balance. The third article is Conservation Drones, Revolutionizing Wildlife Monitoring by Sandra Johnson. The article explores how drones combined with AI are transferring wildlife monitoring. The authors explain that drones equipped with cameras and thermal sensors can collect real-time data in remote or hard-to-reach areas, allowing researchers to track animals, detect predators, and study habits without disturbing the environment. Part 2 of the article, the use of AI enables these systems to automatically process images and videos, identifying different species and tracking their movements over time. The article highlights efficiency, accuracy, and cost effectiveness of this technology, making it a valuable tool for conservationists who need to monitor large or inaccessible areas. The authors conclude that UAVs and AI are creating new possibilities for protecting biodiversity and managing conservation efforts more effectively. In relation of article to topic, this article relates to the topic of computational sustainability by showing how technology like drones and AI can be used to support biodiversity conservation, which is a crucial part of managing the environment's sustainability. It highlights how computational tools can solve real-world ecological problems such as trafficking endangered species and preventing illegal activities like poaching. The use of UAVs and AI reflects the goals of computational sustainability by applying innovative tech-based solutions to protect natural ecosystems and promote long-term environmental health. This connection shows how technology can make conservation efforts more efficient, accurate, and impactful. And the last article is Computational Approaches to Sustainable Urban Development by Dr. Michael Perez. The article, A Computational Approach to Integrating Non-Structural Flood Risk Mitigation Strategies into Urban Planning Process, examines how computational tools can improve urban planning, especially in managing flood risk. The study emphasizes non-structural strategies such as smarter land use, planning, and zoning regulations as alternatives to traditional flood defenses like levees or dams. By combining hydraulic modeling with urban planning data, the research offers a framework that helps cities planners predict flood risk and develop more sustainable, resilient urban environments. The article shows that using computational models allow for better decision making in city design, helping to reduce the impacts of flooding while supporting long-term environmental and social sustainability. In relation of article to topic, the article relates to the topic of computational sustainability by showing how computational tools can support sustainable urban development, a key focus of the field. It demonstrates that through modeling and data-driven simulations, cities and more effectively for environmental risk like flooding, leading to safer and more resilient communities. The emphasis on non-structural strategies such as land use planning informed by computational analysis aligns with the goal of using technology to solve environmental challenges in a sustainable way. This connection highlights how computational sustainability can guide smarter urban design, reducing both ecological impact and vulnerability to climate related events. And here's my works cited. Thank you.